follow and understand. Our chapter is known as linear programming. Again, very easy logic based chapter. Okay, we'll have a little bit of talk before we start this chapter. Linear programming. Later you will see there is nothing of any programming that you might be thinking. Qualifies for 5 marks for us. Okay, now this chapter is more of when you study MBA. When you study MBA, you have something called ORT. ORT means we call operations, research, and technique. It is like that. I mean, this got a lot of importance during World War period, and the chapter is all about optimization. Optimization. Now, what does optimization means? Every time that we deal with resources, we will not have enough of resources. Whatever you want to do in this world, you cannot do everything that you wish. So we say, what is the optimum choice, right? Like when we were a kid, somebody used to say, this is your comics will cost this much chocolate, take any one. Then you think what is optimum. What is optimum for you may not be optimum for someone else. Now this is a typical business related chapter. Okay, so let's try to understand with one story which is related to your book. The problems here you will get will be diet based, transportation based, manufacturing based, and this was all about something like World War days. This used to happen. Now let's take the case of say Ratnadeep out here. Okay, now Ratnadeep sells so many types of products and they have got a storage shelf area, a shelf area which has, you know, let's say the soaps area. You do see 2 to 3 different type of soaps out there. Every soap has a different price. Then there are 2 factors to it. Every soap has a different profitability for them. Sometimes when you go to a store, the shopkeeper might be interested to push a particular product to you because that product gives him a more margin. Are you understanding? But it might not be of your choice. You still would like to buy a shampoo which is likable to you, but not likable in terms of margin for the shopkeeper. But if you go and say, do you have that shampoo? And he says, no, I don't have. Then you'll give a bad review about the shop that they never stock what things we want. Are you understanding? So as a shopkeeper, let's see what are the problems that I face every day. I have a limited space. Do you agree? I have a limited amount of money with which I will buy shampoos. I have to buy and stock, right? There is a shampoo A, there is a shampoo B. And then there's a different type of profitability that I get out of shampoo A and a shampoo B. This happens in, say, children type of baby food, diapers, everything. We have got a choice. As a shopkeeper, what is the best choice of a mixture that you should buy? They're very interesting problems. Are you understanding? Given all these type of what we call limitations on you, you don't have all the money in the world, you don't have all the storage space in the world, you have profitability different type, you have a consumer base who is going to ask you in different types, what is the optimum way you should stack? So the chapter is all about optimization. So let's try and understand. So let's say you are a business person. Okay, you are a business person and you do business. Okay, why is a business done? A business is done with the sole interest of earning profit legally, right? So as a business person, you will have something which is known as profit, which will be getting into your mind. The profit is going to increase your turnover, and you are going to do what? You should be looking on maximizing this profit. Yes or no? Maximizing this profit. And that is what is your sole objective of running the business at the end of the day. Understood? Let's say you are a person who will be rationing food today for the hostel's kitchen. Your thing will be minimizing wastage. It does not mean that every time our objective is all about maximizing. Our objective may be of minimizing also. Minimize wastages. Are you understanding? Okay, so let's take one problem. Let's say there is a person in business, okay, and there are 2 types of products that he actually stocks. This is one type of product and this is one type, right? This fellow has something around say 50,000 rupees in his hands, 50,000 rupees in his hands, and this product is costing him, let's say 2,500 per piece, and this product costs him around, say, 2,000 rupees per piece. Are you understanding? This much is clear. On selling this product, say he makes a profit of, say, 200 rupees. Okay. However, on let's make it a little bit more interesting. Let's say on selling this product, he makes, okay, 200 rupees. However, on selling this product, he makes a profit of 250 rupees. Two are of different brands, right? What should be the count of this and this product that this shopkeeper should store, which is his optimum choice for his business? Now, first try to understand the problem's context. A shopkeeper stacks two type of products. Say these are baby foods or these are chocolate milk, Bonvita and Horlicks. One costs 2,500 per piece, one costs 2,000 rupees. 2,000 if I sell per piece, I get a profit of how much? 250 rupees. And this one I get a profit of 200 rupees. People who come to my shop can either ask for this also, this also. Eitherly you will say, sir, why are you then buying this thing at all? This is giving you more profit. Stock only this, but there are many people who buy this. And if they don't get it, they put a bad review on my shop. So I need to stock this. Now the question arises, what is the optimum quantity of these two that you should stock? This is the chapter of linear programming all about. What is the optimum quantity of these two that you should stock? Understood? This sort of problems, when we will try to do, then our job will be something like this. Okay, our job will be first to break down, our job will be something to break down what is known as, we will have something called an objective function. Always try to identify the objective function. What is the objective function of this type of a business? To earn profit. And this objective function you have to identify in any problem, and this will come in two ways. Either you have to look for its maximum or you have to look for its minimum. We will see. Ultimately ये story को तो numbers में डालना होगा ना, otherwise our problem solve नहीं होगा. Tough लग रहा है क्या अभी तक भी? Okay. Then we will see. Next is we have to identify what are the constraints that are there in this problem. You have to find some constraints. And in these constraints, there can be some which are also known as non-zero constraints. Non-zero constraints. Itna dimag matlab, don't try to overthink on it. Things will become very easy. Non-zero constraints. Let's put this entire scenario into numbers now and try to see. Okay. Ultimately, we have to tell how many numbers of this and how many numbers of this does he stock, right? So let's say the products are A and this is a product B. Let's say he buys X. This is the optimum. He buys X number of this and he buys how many? Y number of B products. Have you understood? Right. I think some constraints I can make straight away, that to buy X numbers, I would be paying how much beta? 2,500 X. I will shell out to buy so many products. And to buy B, I will shell out how much? 2,000 Y. How much money am I carrying in my pocket? 50,000. That's the maximum I can spend. This is called mapping constraints. Story has to be mapped into a mathematical constraint. This is your first mathematical constraint. Do you agree? End of the day, या तो 50,000 पूरा खर्च करो या उसमें से कम करो. अच्छा. Then I told you there are some non-zero constraint. The shop is such that you have to stack both A and B. Do you agree? So we will say in this case, X has to be greater than 0, I'll say. X has to be greater than 0. Or say, I say, don't stack X at all. Tumhari marzi. You buy only B. X means the number of this baby food. You buy either one packet or you don't buy at all. You buy all. And my third one will be Y also similarly greater than equal to 0. ठीक है ना? आपको और कोई कंस्ट्रेंट दिख रहा है? मतलब इस आदमी की जिंदगी की प्रॉब्लम्स देखो आप. These are his problems mathematically. अब business क्यों कर रहा है? Why is he doing the business? Or his profit? तो अगर आप बिजनेस के प्रॉफिट को देखो, you try to see the objective function. Now you have to also understand how to map the objective function. Okay, by selling each piece of X, how much he is earning? 200 rupees as a profit. 200 rupees he earns per piece of X. He has bought X pieces. He will be selling all X pieces. And 250 rupees he earns on selling every piece of Y. Yes or no? Don't you think that this is his, in economics language, his profit function? His profit function is this. Our job will be choose X and Y such that this function yields the maximum value. Not 50,000. Max, this is profit. This is your investment. I should maximize this. This is the function, right? For every value of X and Y, you will get a profit. You're supposed to maximize it. So sometimes it may be profit function, sometimes it may be revenue, sometimes it may be minimizing something. So in the language of what you call, in the language of linear programming, we actually represent it by the letter Z. Z is my objective function, and I would like to maximize this function. So the problem is now like this. Get me the values of X and Y which obey these. These are what? No, constraints for a businessman. Now you're a mathematician. These are inequalities. These are inequalities which obey these inequalities, right? And yet throw me a maximum value for Z. समझ में आ रहा है? ऐसा हो सकता है कि X कुछ खरीदो ही मत. Don't buy. Okay, we don't buy. And buy 10 pieces of Y. So 10 pieces of Y will give you how much profit? 2,500. See here, 10 should be greater than 0. 10 should be greater than 0. Yes, satisfied. And if I add 10 here, I'm not buying anything of this. If I buy 10 here, it is 20,000. It does satisfy. But is it giving me the maximum value? No. So then you've got it. The hunt is to find the maximum value. And to find this maximum value, we do it in only one way, which is a graphical method. That's why we ask for graph books. Graphical method. Okay, ये समझ में आया तो इतना तक, हाँ? Graphical method. And then the first exercise will be teaching you all about solving graphically, and the next exercise will be all real life problems. Have you understood? Now, something more interesting that gets into it is, okay, something more interesting that gets into it. The problem will now boil down and take you to grade 11. First, we should understand the concept of inequalities. पता नहीं आपने कितना ठीक से पढ़ा है, so I'd like to revisit inequalities. Right. So let's go to inequalities. Then we'll see how to graph inequalities. If you don't know that, you can't do this. Okay? अब linear programming has been kept in abeyance. Have you understood? We have gone back. Honey, इससे पहले inequality. Okay. Children, look here. X is equal to 5. This is called an equality or an equation. Okay. Inequality can be X greater than 5, X less than 5, X greater than equal to 5, X less than equal to 5. Have you understood? These are called inequalities. In these two cases, we say that this is a strict inequality. Strict inequality. These we say are slack inequality. If this will also help you in continuity and differentiation. You should understand slack. You're being very generous. 5 or greater than 5. This is strict inequality. This concept is clear. If this concept is clear, let us go to the next part, which is called graphing inequality. Now, don't use your graph book straight away. First, you understand what is graphing inequality, then we'll see how to graph. Okay, Let's see how to graph inequalities. Now, okay. Let's try to graph one inequality, and I'll take some examples in which your job will be getting easy. Suppose you get something like, say, y minus 2x is equal to 3. Y minus 2x is equal to 3, or let me make it more interesting. Y minus 2 by 3x is it has to be an inequality, is say less than equal to 3. इसको ग्राफ करना है हमें, पहले ये सीखिए how to graph this steps, because this is what will be required in your solving problems, right? So how do we graph it? First step will be, forget that it is an inequality and try to read this as an equality. So you will read this as how? Y minus 2x by 3 is equal to 3. This is how you will read it. Convert it into an equality. Understood? After that, as I told you in grade 10, grade 9, the easiest way here is always try to bring it into the format of y equal to mx plus c, where c is your y-intercept. Itna time nahi rahega aapke paas, like a kiddo to make tables and all, and m is your slope, and the slope is always given by rise over run. ठीक है ना? इसको अगर हम कन्वर्ट करें तो ये बन जाएगा y equal to 2x by 3 plus 3. Understood? So my first point is, so let's put some points out here. Let's say 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. And 1, 2, 3, 4, 5. Okay? And this is your origin 0. Okay. Your first job will be always to get the point with the y-intercept. What is the y-intercept? C. Y equal to mx plus c. So this is your c. So one point will be always, one of the point will be 0, c will always be one of the point. So here 0, 3. That means 1, 2, 3. This is one of my point. Agreed? Then we will look at the slope. So let's look at the slope. The slope is read as rise over run. Okay, so let's see. My rise is equal to how much in this question? Positive 2. Positive 2 means we climb upwards. Positive rise means if the rise is positive, you go up. If the rise is negative, you go down. Okay, and then we have a run. How much is the run? The run is positive 3. If the run is positive, you go this side. If the run is negative, then you will be going this side. But from where? From the point that you have selected. So what is this point? ये पहला वाला point क्या हो गया हमारा? ये है 0, 3. ठीक है ना? आइए. So how much is our rise? Our rise is 2. So we will climb 2 from here, 4, 5, and I've come here. Agreed? And then my run is 3. So I run on the right hand side, 1, 2, 3. So my next point would be somewhere here. Agreed? And then, sorry, this would be my next point. And my next job would be now to draw the line. Okay, now to draw the line. As I draw the line, you should also be, अच्छा, अभी देखो, now my job is to draw the line. So let's say I take a line which passes through these two. Okay, now try and understand. Okay, understood? But this line is actually towards our inequality. What is the inequality? Y minus 2x by 3 is equal to 3. समझ में आया बच्चा? Okay, now hold on. If your inequality is slack, that means an equal also holds, a less also holds. In that case, we always draw solid line. If your inequality is slack, we draw solid line. Solid line means points on the line also qualify. Points on the line also qualify. Did you understand? And if it is a strict inequality, we will draw dotted line. Dotted line, what does the line represent? See, Zoe, what does the line? The line is an equations line. You are not solving equation, you are solving inequality. Therefore, you make a dotted line and you say points on the line don't qualify. Acha. In grade 10, when you used to find for solution, or used to suppose this is this linear equation, okay, a linear equation in two variables. Go to grade 9 now. In grade 9, we used to say, what is the solution of this? All points that lie on this line. All points that lie on this line. So how many solutions? Infinitely many solutions. But now it is no more a, what you call solution. Now it is a, sorry, it's a equality, it's an inequality. See, somebody's, if this fits, anyways, it will go waste otherwise. Okay, it's an inequality. So in an inequality, we won't have a particular infinitely type or an infinite, we will have a region. What will we have? A region. Now the question arises, this line is coming from here to here. The region can be above this, the region can be below this. Have you understood? How do we understand which region supports us? These are all grade 11 things that we are doing. In order to do that, you will first take something which is known as a, your first job will be, once you have done this, take one test point. And test point is always taken as an easy point. The best test point is 0, 0. 0, 0. Unless the graph goes over 0, 0. If the graph would have gone over 0, 0, then we don't take 0, 0. Then you can take a 1, 1, minus 1, 1. Take an easy point, right? And feed this out here. Feed this point out here. So what is your left hand side going to be? 0 minus 0. Oh, sorry, one small mistake I have done. This is an inequality, children. Oh, this is an inequality. I should have written it as an inequality. Y minus 2x by 3 is less than equal to 3. Okay, so we feed 0, 0 on that particular, what do you call, we'll be feeding 0, 0 on that inequality. So look at the left hand side. What is the left hand side equaling to? 0 minus 0. So left hand side is 0, right? What is the right hand side? The right hand side is 3. Means you have established 0 is less than or equal to 3. 0 is less than or equal to 3. Is it a true statement? Yes. That means 0 lies, the point that you chose lies in your region, in the region of solution. मतलब अपना solution अभी किस side होगा? ये side वाला अपना solution होगा. Did you understand that? 0, 0 origin has satisfied you. If this question would have been greater than equal to, see the beauty, if this was greater than equal to, then also you would have drawn the same line, but in that case this would have resulted in 0 is coming as greater than equal to 3, which is false. So 0 does not lie on our region must be beyond this line. Samajh mein aaya? So now I will say that what is your solution? The solution for this particular inequality is entire this region. So some people show it like this. See, they will draw 2 arrows out here rather than mutating the whole drawing. This is your solution zone. Everything that is here will be satisfying. Achha, just check once. Just check once. What is this point, beta? This is 0, 4. Dal yahan pe 0, 4. 0, 4 means put this 0. 4. 4 is less than equal to 3. Is it true? No. So this lies outside my region. Is this thing coming clear to you? Your ability to draw the graph should be quick. Okay, suppose you get the equation which is not coming so easily in y equal to mx plus c, but they have given you standard form of the equation, something like this: ax plus by, say, plus c equal to 0, or I'm writing this as, say, plus c equal to 0. In this format, they have given you the equation or inequality. Whatever is the inequality, this is the equation. Understood? इसको कैसे सॉल्व करते हैं फटाक से ग्राफ में? तो ये कैसा हो जाएगा? ax plus by equal to negative c. Understood? Here what we do, once choose x as 0, once choose y as 0. You'll get the 2 points quickly. Means you go for the intercept. If you put x as 0, this part vanishes. You just get y equal to some blah blah. So you get x as 0, then y equal to some blah blah, 1 point. And the second point, you'll put y equal to 0, then you get the value for x. Have you understood how to draw inequalities and how to find which region your inequality passes through? One more thing. Let's say our equation was y equal to 3x. Y equal to 3x will be, now look at y equal to 3x, means it is, y-intercept is 0 now. It will pass through the origin. Now don't take the test point as 0, 0. Take some 1, 1, minus 1, minus 1, 1, minus 1, whatever is it. You can't take 0, 0 in that case. And then you see whether the test point satisfies this inequality or not. If it satisfies, the test point belongs to your solution region. And if, shall we go back to linear programming now? Okay. So let's go to linear programming now. Okay. So you remember this, okay? So let's take this. So let us now go back to our original problem. And our original problem was something like this. Correct me if I'm wrong. So I had an objective function, children, which said that z is equal to, how much was it? 200 rupees profit on every x plus 250 rupees profit on every y. This will be known as my objective function. Objective function, and my lookout is to maximize it. Clear ho gaya bacha? This is my objective function. Okay, let's look on my constraints. Let's look on my constraints. Sorry, you open the window. I think I didn't open the window. Yeah, let's look at my constraints. My first constraint was my investment, and the investment was in what order? That 2500x plus 2000y should be less than equal to 50,000. Okay, you should also write these things, huh? Let x be the number of product A that we will buy, y be the number of product B. My next thing was x should be greater than equal to 0, y should be greater than equal to 0. I did not find any other constraints in this problem. Right. So our job will be now to draw these three inequalities first. Then only, isko kuch nahi karna hai. There they will tell you what is the maximum profit you can get, or what should be the numbers that you should buy to yield the maximum profit, right? So here you have nothing to do. Your job is out here. So let's make our Cartesian coordinate system in that time frame. I didn't get you, Zoe. Come again. Yeah. You have to draw one graph, everything. All will be in one graph. Optimization hai na? So you will get a region which satisfied blah, blah, and blah. Don't use the graph book now. Now just enjoy the problem. The graph book आप बाद में भी कर सकते हो. Okay. ये equation को थोड़ा छोटा कर सकते हैं. देखो तो. इसमें we can take out all the double zeros. After that, what do we do? 5 say. So this equation will become 5x plus 4y is less than equal to 100. ठीक है? और नीचे नहीं जाता है. Same thing. इसको प्लॉट करें. Now this is coming at what is it coming as? It is coming as standard form ax plus by. तो इसको आप कैसे read करोगे? You will read this as 5x plus 4y equal to 100. इसको प्लॉट करना है हमें. तो सबसे पहले एक ले लेते हैं. When x is equal to 0, then what do you get? Y is equal to 25. Yes or no? Okay. And then what do we get? When y is equal to 0, then x value is equal to 20. So 2 points we have obtained. Right? So let this be 5, 10, 15, 20, 25. 5, 10, 15, 20, 25. You have to write scales also. I hope that much I am not going in depth. X dash 5, 10, 15, 20, 25. Y dash and Y and 5, 10, 15, 15, 20, 25. This is my 0. And I put my scale x-axis, let's say 1 cm gives me 5 units, and y-axis 1 cm gives me 5 units. अच्छा, क्लियर यहां तक? ठीक है, चलो इसको प्लॉट करें. जब x 0 है तो y कितना है? 25. 5, 10, 15, 20, 25. So this is my 1 point, right? And the next point is when y is 0, then x is 20. 5, 10, 15, 20. This is one more point. So I'm ready to draw my first line. Okay. So more or less, right? Ready? Okay, and I write this as, this is 5x, this is 5x, this is 5x plus 4y is less than equal to 100. Children, why did I draw a solid line? Because it's a slack inequality. Understood? My next inequality is what? X greater than 0. So I will read this inequality and in what manner? I will read this inequality as x equal to 0. X equal to 0 is nothing but my y-axis, and this is to be read as y equal to 0, which is nothing but my x-axis. Have you understood? Now there can be two options which will come up. Either you may get a bounded region or you may get a unbounded region. Right now we are getting a bounded region. Have you seen? Anyway, this will be the point below this. Just put 0 out here. Put 0 out here. 0, 0. 0 is less than 100. 0 is less than 100, which is a true statement. That means this side of this line qualifies. Again, you have to give utmost respect to the y-axis also. Greater than, anything greater than. You can't produce in negatives. So y-axis is anything greater than, in x-axis is anything positive. So what is your region? My region, which actually is my feasible region. Now this particular region, this is known in linear programming as my feasible region. Any point that you pick up here will satisfy all your constraints. Will that maximize your objective function? We don't know. Have you understood? ये आपको जगह मिल गया, आपको इसके बीच में ही रखना है जो भी सॉल्यूशन रखेंगे. अच्छा, now come here. Now some beautiful points will come up. What is the shape that has formed, beta? The shape is a triangle. Therefore, this one, and this one, they will constitute what is known as corner points, CP1, CP2 and CP3. CP1, CP2, CP3. समझ में आया बच्चा? So here what we make now is known as a corner point table. Now we will make a corner point table. This is my corner points. How many corner points I have? 0, 0. Then this one was how much? 5, 10, 15, 20. So this is 0, 20. This is 0, 0. This is, this is 0, 25. And this one is 20, 0. My mistake. This one is 20, 0. Okay? So we have, you can put another one column which says serial number और सुंदर लगेगा देखने के लिए 025. Understood? And here you write your objective function. What is the objective function? 200x plus 250y. Okay? If you take 0, 0, what is the profit you are doing? 0. Obviously, you didn't buy any product. How do you expect any profit to come? Okay. You did not buy, see, you did not buy any of this, what you call, say 200 is for x, 20 is for x, okay? And you are not buying y. So multiply 2 into 2 is, 2 into 20 is how much? 40. 40, so 40 and 00. So here we will be getting z's value as how much? 4000. Agreed? And here we will get z's value as how much? 25 into 25 is 625. 6250. Okay. Now this is a theoretical problem where they have allowed you, that you can even opt not to buy any product at all, a particular product. So what is your answer at the end of the day? That as a shopkeeper, if you want to maximize your profit, considering all these constraints, please buy 25 numbers of what? Y items that will give you maximum profit. So if you buy 25 numbers of Y, then tell me how much are you spending? How much are you spending? 25, 25, 625. Is it matching your fund?
Yes.
You should be less than 50,000. Not that. 25 products you are buying of 2,000 rupees each. So how much is your investment? 50,000. Is it well within your limit? Yes, it is well within my limit. Right? Have you satisfied this condition? Yes. Have you satisfied this? Yes. Have you satisfied this? Now let's for some time, let's say our friend say Neha does not agree. Says sir एक दूसरा point try करके देखो ना. करके देखते हैं चलो. ये point कितना है? This is 5, this is 5, right? So यहाँ पे एक point क्या आ जाएगा? 5, 5. 5, 5 is also within the feasible solution. जरा 5, 5 में plot करके देखना कितना profit होता है हमें. 5, 5. 5 into 200 will give me how much? 1000. 1000. And 5 into 25 will give me 1250. So how much is it? 250. You are not getting the maximum profit. So one thing we have understood, that if the region is bounded, the corner points will always have the maximum value. Not for a triangle, it can be a polygon. Now I'm giving you 3 constraints. If I would have given you 4 constraints, some more chopping might have happened. It can be a bounded, means it's a closed polygon. You have to find out every corner point's coordinate. Those coordinates will only qualify for the maximization of the objective function. But for that, you have to make this table and show. And then you have to give the inference, the shopkeeper, in order to maximize his profit, should buy how many? 25 numbers of article B, considering all the constraints. Ye clear hua? Now the question comes, sir, what if I do not get a bounded region? That is also possible, na? I do not get a bounded region. मतलब कैसा? अच्छा ये clear हुआ आपको? And you at home you go and do. Your first exercise is all about, they won't tell you any such problem. They will give you just solve graphically 4 inequalities. No objective function will be there. First exercise में कोई आपको objective या फिर दे देगा एक objective function, because you have to show what is the maximum value. Initially they'll just show draw. आप अपना हाथ ठीक करो. Then they will give you show this. Second exercise will have all problems. A man has to deliver 3 shops. Which route should he take? Optimization ना end of the day. ठीक है? आप मान लो आपका सिनारियो कुछ ऐसा हो जाता है. Your scenario is something like this. Say unbounded. We are getting something called unbounded. Right. And there is, say you got a constraint like this. Say you got, there is another constraint given to you, which is like this. And X and Y are already there. So if you see your feasible region now, if I, sorry, इसमें redo नहीं होता है, all gone. This is one, and let's say this is one more. Now if I try to look at your feasible region, okay, let's say we are trying to look at your feasible region. This is one corner point, okay. X and Y axis will also qualify. This is one corner point. This is one corner point. Your feasible region has become like this. Unbounded. Have you understood? It has become unbounded. In such a case, does the maximum value, does the solution maximum value lie out here? We will say, again, we will analyze corner points. There are 2 criteria. If there is a feasible solution, then it is one of the corner points only. Listen to me. If there is a feasible solution, this is unbounded beta. ये यहाँ पे infinitely जा रहा है. Which point will you consider? ये मुझे नहीं पता. If there exists a feasible solution, it has to be these corner points only. And if there is no feasible solution, then even these corner points won't be will yield any maximum value or minimum value. Try to understand. If there exists a feasible solution, it will be either of these corner points. Now the question comes, how do I know whether there is a feasible solution or not? Have you understood? So, इसको ही थोड़ा समझने का होता है. So I can get 2 type of objective functions. I can get an objective function which can be either a maximize or a minimize. So let's say objective function, and I will get the objective function to be a maximize or a minimize objective function. Children, have you understood minimize? The problem can be of losses. Okay. And in Cambridge earlier, it was in grade 10. Very nice questions is to give. A football franchisee starts preparing a football team with sufficient amount of money, like an IPL, you have this much of money. Your idea is to have at least 8 striker batsmen, 5 bowlers, 2 wicket keepers, 3 spinners, and these are the contract rates of each of these players. Find the optimum mix of the team so that the investment of hiring these players is minimum. Have you understood? So there will be a lot of constraint. So here it will be either an maximize or minimize. Now what we will do here, children, in this type of problem also, you will make your corner points. So we will make our same table. We will have our corner points and we will have our objective function. Now this is typically the case of unbounded. Unbounded. Beta unbounded में solution can be there, may not be. May not be. And if the solution is there, it is one of CPs, one of the corner points. Agar hai to one of the corner points. Our job is to say, how do we decide between this, whether it's there or not? So how many corner points you have? CP1, CP2, CP3. There can have been CP4, 5 also, right? So I write my corner points CP1, CP2, CP3. After solving these, say for CP1, I got the minimum value, and for CP3, I got the maximum value. Children, do you understand this? Minimum, and this is the maximum of what? The objective function. Then I look into my problem. What was my problem all about? What is your problem? Say our problem was, let's say our problem was about a maximizing problem. तो हम ये मैक्स वैल्यू वाला ही लेंगे. मैक्स वैल्यू इज m. समझ में आया? समझ में आया? और ऑब्जेक्टिव फंक्शन मान लो कुछ ऐसा था, z is equal to px plus qy. This was your objective function, right? So now what we will do, we will take our objective function as px plus qy, right? And this is m. Now look at me. M is the maximum value that you got, and you are solving for a maximum problem. Is this getting clear so far? So we will take our objective function and we will make an inequality greater than m. Why I am doing this? Right now the 3 corner points I got, this is the maximum value for this combination of this will be some x1 and some y1. Yes or no, bacha? This is a maximum value. My doubt is there a value bigger than this? Is there some other x1 y1 in which I can obtain a value greater than m? That's what I'm trying to check. Therefore I have made the equation as greater than m. And I will plot this line also. Now, what is this line? It's a strict inequality. It's a strict inequality. So I will plot it in what manner, beta? Px plus qy is equal to capital M. हम plot करेंगे. समझ में आया? मान लो उस लाइन को हमने प्लॉट किया. ओके, मान लो हमने उस लाइन को प्लॉट कर दिया और वो लाइन कुछ ऐसा आया. अच्छा, what is this line? This line is, now this should be dotted, huh, children? This should be dotted. Okay, let me draw a dotted line only. Let me draw a dotted line. Now this should be dotted. So let's say the line has come like this, and this is my line, and I write this as px plus qy greater than m. Greater than m. So you have to find out which is the zone greater than m. Here it doesn't bother you, because whether if you have a greater or a less, you have somehow entered the feasible region. After drawing this line, we will get 2 parts to this line or this line. Now this is a greater. So let's say this part of the line, let's say the inequality is like this. The line is, this is the feasible region for px plus qy. Now ask yourself a question. What is the feasible region of the dotted line? Anything that is up from here. Does this have a common region, share some common points with my original unbound? Yes, my original unbound is all on this side, and it is sharing. It is sharing. In that case, there is a solution, and this itself is the solution. Go back once again. What did I say? Unbounded will always have a solution. Unbounded may have a solution, may not have. If it has a solution, it is either of these 3 points only. Already analyzing these 3 points, right now you're finding he is leading. He is leading, right? You just want to check whether there's a better answer than him or not. So find that better answer. You plotted one more inequality. After plotting that inequality, you will check whether that inequality and your original unbound space shares common points or not. They are sharing, all these points are common. The value will not come. This is greater. Your function is equal to. You yourself made it greater. ये share नहीं करेगा उसके साथ. So that is then what is my solution? Any of the existing earlier corner points is my solution, which I have already solved. That this is my solution. There is a solution. Now there can be another scenario. That now don't get it confused. Huh? Say suppose px plus qy कोई function था और वो function ऐसा plot हो गया. That function got plotted like this. Now its region is where, or say not this way. Let me say नहीं ऐसा नहीं. And let me, okay, this is fine. And let's say this is the region. All points on this side. What was your unbounded region? This side. Is there any common point? No. Such a problem does not have any solution. We cannot say. There is no solution. What numbers of A and B he should buy? We don't know. Given the constraints, we are unable to give you any numbers. So please change your constraints. समझ में आ रहा है? अगर ये problem minimum को लेके होता ना, then we would have formulated the same equation. We would have formulated as px plus qy less than this small m. Minimum. No, Zoe, not like that. We will revise this whole problem once from this part, okay? Did you understand this problem or not? In this problem, what happened is that we came across a feasible region, which is no more a bounded region. It is open on one side. But as it is open on one side, we still can find some corner points, whatever you could find. So you formulated the corner point table. Then you ask yourself, are you doing a maximizing problem or a minimizing problem? Let's say you're doing a maximizing problem. For these 3 or 5 or 6 choices, it can be 6, 7 corner points also, and dig, like this. You found a maximum value, right? You still cannot say that this is the optimum. That you can say only if a solution exists. Bonded ke case mein, once you get this, yes, solution exists. Here you can't say that now. To say that, you need to perform one more test. What is that test? Pick up your objective function and form an inequality with this maximum value with greater, because आप maximize कर रहे हो, and plot this inequality in your chart. You plotted this inequality in this manner, and then see whether this is, for this particular inequality, it is this region or that region. In this problem, that question does not make any sense, because for this region also there are common points, for this region also there are common points, but it will be only one region. Yes or no? So we have some common points out here. Once you see that there are common points, you will say solution exists. What is the solution? By the maximum that you got, that was your solution. However, if your line was like this and it was plotting a region on this side, it's an inequality at the end of the day, and your unbounded starts from here, are there any common points? Solution does not exist. None of these are your solution, right? So we cover it up in this manner. So we will cover it up like this. For what spellings I'm writing nowadays? For unbounded region, feasible solution may exist may exist, may not exist. And if it exists, it's one of the CPs. And it can be a maximum or a minimum based on your objective function. Means if you are doing a maximum, then the maximum is the solution, may or may not exist. And if it does not exist, there is no feasible solution. Have you understood this much? Okay.
Sir, can you go back to the previous slide?
हाँ, क्या डाउट है बोलो पहले, क्या डाउट?
So after we made the dotted line, अगर हमको left side feasible region,
If the dotted line creates a region, dotted line is not a line, it's an inequality. So it will have either a position above it or a position below it. So let's say the position below it is the qualifying part. That position below it and the unbounded should have common points. That's what I'm writing. May exist. Now, how to check this? For this, map another inequality. And what is that inequality? That inequality will be your objective function, which I'm stating as, say, z equal to px plus qy. Say this is your objective function, right? And one of the corner points where max value is coming as m, minimum value is coming as m, right? And let's say our problem is about maximizing. Then another one we will make as px plus qy is greater than m. We will plot this. Map another inequality. We'll map this. Or if you are doing for this is for maximum. If you are doing for minimum, then it will be px plus qy less than m. This is for minimum. समझ में आया? ठीक है? Map another inequality, and then in both these cases, look for common points between the new inequality region and the existing unbounded region. Your answer can be yes or a no. If it is yes or no, declare one of the corner points. If it is no, means no solution. इसे ज़्यादा क्लियर नहीं कर सकता हूँ, देखो समझ में आएगी नहीं. ठीक है? Understood now? So if you have an unbounded region, there is a feasible solution, may exist, may not exist. If it exists, it's one of the corner points. If it does not exist, no feasible solution. This is basically the same fang that I've drawn here. How to check whether it exists or not? Map another inequality. If you were doing a maximizing problem, take the maximum value from the corner points. If you're doing a minimum problem, take the minimum. Just make sure minimum में minimum हो जाएगा, ये less than हो जाएगा, ये maximum हो जाएगा. तो solve करेंगे, फिर आपको होना शुरू हो जाएगा. Clear इतना तक? एक मिनट अपना टेक्स्ट बुक खोलिए अभी, if you have, and if you see your first exercise, just example 1, say for example, I'll just show you. Let's see this problem, okay? Let's see this problem. So just look at this problem. Look at this problem. Don't look at the dotted line first. Don't look at the dotted line first. Okay? This is somewhat like a polygon. Do you see? And it is unbounded. Imagine that everything is sky blue. Imagine everything is sky blue. Everything is sky blue. Now it is unbounded. Do you see the corner point table? It is right next to it, right? And the question is all about minimum value of this function. We have to find minimum value, right? We have to find the minimum value. So if you see, minus 300 is the minimum value. And what is the objective function? Minus 50x plus 20y. Have you seen? So they have now taken it as minus 15x plus 20y. Okay, इसको हम minimum कर देते हैं. If you see this thing, minus 50x plus 20y, look here, is less than minus 300. Have you seen? And that is the dotted line which they have drawn. That is the dotted line which they have drawn. And after drawing the dotted line, the deep blue portion is now, which is common for the original after drawing the, so there is a minimum value. And the minimum value will be one of the corner points value, which is already you have found out. Clear हुआ आपको भी? 5 minutes है, एक बार फिर बोल देता हूँ, रफ ड्राइंग है, अनबाउंडेड रीजन, और कॉम्प्लिकेट करके करते हैं, आ जाओ, अनबाउंडेड. Okay, say one line went like this, one line went like this, another one line went like this, and another line went like this. ऐसा है unbounded region आपका, ठीक है? Or say another line is going like this. So let's first see what is the region you are getting. This one, this one, this one, and this one. Agreed? What are your corner points? This, this, this. 3 corner points we have. Right? Let's say this was a maximizing problem. And the objective function is something like z equal to 3x plus 2y. Oh, this is your objective. And we have solved for corner point 1, corner point 2, corner point 3. And CP3 is basically x3, y3, which is yielding a value of z, which is equal to say 400. And so means other values will be something like 120, 260. ये maximum value है. इसको हम क्या बोलेंगे बेटा? M बोलेंगे. अब हम एक नया inequality बनाएंगे. What is the नया inequality? The नया inequality will be 3x plus 2y greater than 400. इसको प्लॉट करेंगे, ठीक है? और इसको हमने प्लॉट किया और प्लॉटिंग कुछ ऐसा आ गया, प्लॉटिंग ऐसा आ गया, ग्रेटर देन है. नाउ फॉर दिस लाइन एंड दिस इनइक्वालिटी आल्सो वी हैव टू डिसाइड ये साइड या वो साइड. इट वाज सच दैट दिस साइड इज द क्वालिफाइंग साइड. It's sweeping. Do you not think it will sweep this region also? Common points exist? Yes. This is the max solution. And if it was like this, do you have common points? No. Same problem. Suppose this problem was about minimizing. So I'll do it with blue now. Problem was about, and this is my minimum point, M. Now my function will be 3x plus 2y is less than 120. ऐसा लेंगे. ठीक है? And then again we will draw a line. Say that line is something like this. इसमें कुछ सोचना ही नहीं, ऊपर भी क्वालिफाई है, नीचे भी क्वालिफाई. Solution exists. This is my solution. Exercise 1, I have nothing to do. It's all about drawing. You have ample time to draw some lines. Exercise 2 is same questions where we will be more interested to actually solve what you call there the issue is अभी जो तुम्हें ये सब दिख के दिया ना, where Zoe's fingers are there, so just turn Zoe, yeah, put your fingers, yeah, those stories were made easy for you. They gave you all constraint and all. In the next exercise you will see no constraint, nothing. You have to read the problem and formulate. They have got 2 exercises or 1? Okay, it's only 12.1, so they have combined, then it's much more easy.
No, all of them are values.
Oh, all of them are values. Then though it's all fine. And you don't have problems now like this. Oh no, earlier it used to be very interesting, you know. Hey, earlier if you see, तो तुम्हारा job और easy हो गया. 1 class is sufficient. See, earlier we used to have problems like this. It is like The question is, there are two factories located at place P and Q. A truck moves from P to Q. If there's nothing, then share it. So I think it's all exercise 1. Can you show me your exercise 1? Oh, that's it. Oh, this one. You don't get now diet and all. Earlier, it used to be a child is to be diagnosed deficient and is given carbohydrates. There should be very nice food. A shop stacks cat food and dog food. There are some cat lovers, there are some dog lovers. Dog lovers will want dog food also, cat lovers will want cat food also. However, the premium is more in cat food. What should be the shopkeepers? यही CBSE मार देता है problems को. ये कितना interesting है. So then your job is easy. So I don't think we need one more class. Next class we will see if you just practice and see if you have any problem. Otherwise we will straight away move to functions now. It was functions are next. Yeah. And let me just check. Okay, I'll stop the recording.